to this parallel session on sustainable cloud for greener Europe. So I would like to introduce you to the speakers that will share their experience today. So we have John Booth, consultant at Carbon Tree IT. Simon Hinterholzer, is that correct? Researcher at Borderstep. Then we have Andreas Ebert from Microsoft. And finally, Mark Acton from EkkoSense. So I'll immediately give the floor to John to share with us your presentation. So please, John, go ahead. Yes, I will just remind you about the housekeeping rules, and I will give you over the floor. So just inform you that this session will be recorded and that you're been all muted. But if you want to speak, please use your raise your hand button and wait for the moderator to give you the floor. But you can post, of course, your questions to the Zoom chat. And if you have any technical issues, please contact us in the chat. Thanks. So, John, the floor is yours.
Good morning, everyone, and welcome to this Horizon Cloud Summit 2020 and this presentation panel session, Sustainable Cloud for a Greener Europe. My name is John Booth, and I'm the MD of Carbon Tree IT Limited. We're a green IT consultancy, and we celebrated 10 years in business in January. I sit as Technical Director for the NDTA and on a number of standard development organisations related to this topic. And also see that I sit on a number of other bodies related to climate change, energy and data centres. So for this presentation, we're going to go through this brief agenda. What is a data centre? What is sustainable, energy and environmental, and some potential mitigation actions. Right, okay. So what's a data centre? And I suppose it depends on who you talk to. Some viewers may recognise Cloud-Based 9. This was a 1960s television programme. It's where Captain Scarlet and Colonel White lived, and with the angels. And a lot of people think the cloud is actually in the cloud, which is quite alarming. But yes, it depends on who you talk to. But what is a data centre? They range from the most basic converted office with some DX cooling or direct expansion cooling and a couple of racks to some of the world's most complex engineering environments. And we'll have most of the systems that are listed on this slide. And they're there to deliver digital services, i.e. cloud, to customers, be they internal and external. And they should be at the lowest possible cost, depending on your organizational risk profile. The question is whether the 20th century designs that most DC builders are adopting are really the right solution for the 21st century. Now on to sustainable. So sustainability is the ability to be maintained at a certain rate or level, and it's the avoidance of the depletion of natural resources in order to maintain an ecological balance. It raises two key questions. First, can data centres be built and operated at the current rate of growth? And given that every piece of ICT equipment and data centre infrastructure components require natural materials from mineral ores to oil-based products, can we avoid the depletion of those natural resources? So what are the impacts for growth in data centres for cloud? Well, in certain cases, land use, some land could be prime agricultural, raw materials for both mechanical, electrical and ICT equipment, transport energy in moving these components around the planet, the in-use energy, and then finally impact on human health. So I'm just going to go through a couple of data center types. So if your server rack is in a room that's DX cooling, they can be classified as a data center according to the EU Code of Conduct for Data Center Energy Efficiency. And here are some examples, some in-house on-premise data. And this is the inside of the Facebook data center in Luleå in northern Sweden. And this is the outside. And they're currently building up at this area here. To the kind of top of the picture. And this is the Facebook site at Fort Worth in America. And the thing is, there's no current data on the amount of land that's being used for these hyperscale data center projects. Now to the question of periodic elements used in ICT. Picture of an abandoned rare earth mining site in China. Child miners in the Congo, and this is a picture of artisanal mining in the same area. It very much reminds me of the early days of gold mining in South Africa and diamond mining in South Africa, where we can see these pictures. This one here, the one on the right, is the big Kimberley pit, and why you can see those wireways is that individual people had different plots, and of course, if you were efficient and you managed to dig your hole deeper than everybody else, the adjacent plot could be left high and dry, and of course there was dangers there. One of the reasons why consolidated goldfields was created was to human health. And this is something that I wanted to bring up, and I borrowed this slide deck from a colleague at the British Computer Society. So in the before the 1990s, there were 6 elements used in computing equipment. Between 1990 and 2005, a number of elements were added. Since 2005, you can see that most of the periodic table is now in use for ICT equipment, and that's phones, servers, tablets, all sorts of other materials. And then, of course, we come on to the question of e-waste. And studies that have been conducted in China, India, Nigeria, and Ghana have found that e-waste sites contain large concentrations of heavy metals, organic contaminants in the air, dust, soil, and vegetation, and the blood of the workers and residents on or around the vicinity of the site. And this is potentially because those countries don't have very strong environmental laws. And they can cause multiple contamination problems. So now let's touch on actual data center energy use globally. A recent article in Science magazine published earlier this year spoke about the problems of actually ascertaining the data on data center energy use. And what that's happened is it's led to sporadic and often contradictory literature on global data center energy use and the scope of the research. You can find that information on that link. And we've all seen articles that say that data centers use 1% or perhaps 2% or perhaps even 3% of total global energy consumption. Which is interesting. So the Science article estimated that it was about 1.1 to 1.5. And again, as we can see, that's estimated. And that was in 2010. And in 2018, it's around about 1%, which is interesting. Because we've seen explosive growth. And maybe it's because we've shut down some more on-site. Well, there are some recommendations that came out of that report. And one of them was policy support for energy efficient standards for IT equipment, investment in new technologies, and most importantly, I think, public data and modeling. But they warn that the potential of the growth of data construction could lead to a doubling of compute capacity in the next 3 to 4 years, and that policymakers should consider those 3 main areas of action. Now, of course, what we've got in the EU, and we're still awaiting the detail, is that we've got the Green Deal. And we know that the EU have got their targets on data centers and telecoms. And they say that the Commission will be considering measures to improve the energy efficiency and circular economy performance of the sector itself, from broadband networks to data centers and ICT devices. This was in a pre-briefing note last year. They went on to say on February the 19th this year that data centers and telecommunications will need to become more energy efficient. reuse the waste heat energy and use more renewable energy sources. And it's quite interesting that there was a LinkedIn post yesterday where somebody done a survey.
Klein momentje, nee, wacht, want ik ga hier even iets doen.
Okay, so that LinkedIn post said that sustainable energy would be the best way to becoming sustainable. And I had to put a comment saying that an inefficient data center powered by renewable energy is still an inefficient data center. They went on to say that they can and should become climate neutral by 2030, which I think is going to be an interesting dilemma. So coming back to the concept of the data and how much energy is actually being used, as we've seen in the absence of a regulatory and mandatory energy consumption reporting mechanism, estimates are all we have. In 2017, the EU JRC published a report entitled Trends in Data Center Energy Consumption under the European Code of Conduct, determined that the EU Code of Participant data from 289 data centers indicated a total of 3.7 terawatt hours. But in the UK, our climate change agreement data suggested that the UK data center energy consumption for commercial data centers was 2.579. So that means that the EU data centers is only 1.21. There's something wrong with the data. So bearing in mind the inherent materials and fossil fuel energy use present in computing in general, can it ever be considered sustainable?
John, just 1 minute. If you want to wrap up, thanks.
Okay, yeah, fine, okay. Right, so coming back to data centers, we have quintupled processing for a 6% increase in energy consumption between 2010 and 2018. We reduced PUE from 2 plus to 1.7, full designs at full load 1.2, some of the hyperscalers operate at 1.2. We appear to be driving the installation of renewable energy systems with power purchase agreement. We're using the waste heat in greenhouses and district heating, and we've got a lot of innovation in smart cities and integration. Mitigation actions, what do we need to do? They're on there. So I think there's a lot of people that need to get their finger out and start doing stuff. There are the Code of Conduct, which provides good groundwork for this. Elect building standards. Mark will talk about those in a moment. Catalyst project, ISO standards. My takeaway is that the EU Code of Conduct for Data Center Energy Efficiency contains 160 best practices for data center energy efficiency. You can use it to perform a cultural and strategic change within your organization. And I think that we need to start thinking about a global data center sustainability standard, and perhaps the SDO can help us with that. Thank you very much. My name's John Booth. You can find me on this address. I'll now hand you back to the organizers.
Thanks a lot, John. It was a very interesting presentation. Now I see that Paolo Bertoldi has joined us, so there was a little problem with schedules. So Paolo, are you there?
Yes, I'm here. Thank
Perfect.
you very much for introducing me. Can you hear me well?
Yes, perfectly.
Okay.
If you want, you can also share your video.
Yes, okay, let's do that. So again, good morning to everybody. Apologies for being late. Was misunderstanding on the schedule and the starting time. I was jumping through the presentation of John, which has been collaborating with the European Code of Conduct for data center energy efficiency, for which we work since a number of years, and has been very instrumental in promoting energy efficiency in data center, which is just one component of sustainability, but an important one. Let me also say that the topic of sustainability in ICT is very important and has two facets. One side, what John was presenting, the environmental impact, which is not just cloud, but is also any electronic device that may use to join the cloud from a mobile phone to a server. And then the fact that ICT and cloud could have a very important impact on promoting sustainability in optimizing process, system, and operations from today being connected through the internet and not be physically flying to a city, maybe Brussels, and emission of CO2 to flight, consumption of maybe more food, more space in hotels. But not only these examples, also optimization, industrial processes, transport systems, etc. So we should never forget the two coin of the medal, and one should compensate or be bigger than the other, and we should work on both of them. I see the agenda is very busy and very interesting. So without further word, I would like to move to the next speaker, which is Simon Hinterholzer from Borderstep, who is going to present the energy demand of cloud computing in the European Union, insight and takeaways from a recent study for European Commission. Is now a very famous study done for my colleague DG Connect. I think is a landmark study try to identify what is the real energy impact of cloud computing in the EU. The floor is yours, Simon. Thank you.
Thank you very much, Paolo. We had great meetings, I remember, with the study. Thanks also to John Booth, who had a great presentation before. I really liked your slides. They pretty much showed that sustainability is not only energy efficiency and cloud is not only data centers, it's much more. So I will go now specifically for energy efficiency into data centers, which is an important part of cloud computing. So let's go directly into it. The study, which is now downloadable in the internet, was made by the Federal Environmental Agency Austria and us, the Borderstep Institute. So the study was made between December 2018 and May 2020, and we had a huge stakeholder participation, including 2 workshops in Brussels. And I will go directly into some of the results now. And one thing John Booth already perfectly said, that the data on the energy consumption of data centers is a huge problem because, as you can see, you have different studies. The one that John Booth described before was the one of Massanet, and the other one of 2018 was made by Andreas, was based on these figures. And there are some others out there who publishing data on energy consumption of data centers worldwide. These are all figures of the global data center energy consumption. And you can see, especially in the projections for the future, the studies vary greatly. So this is a huge problem, and it was already described by John, that you have different modeling approaches, and we are in contact with some of these authors, like Andre and Massanet of the USA, and we also have developed a bottom-up model, which we are using since 2007, in the beginning mainly for Germany, but we from the beginning collected data on the European sales figures for the data center market. And so we have made our own calculations for the data center energy consumption, which you can see in the slide has been rising between 2010 and 2018 within the European Union 28. And what you can see here is that mainly the amount of energy that is consumed by the ICT equipment, like servers, storage, and network, increased a bit faster than that of the infrastructure, cooling, and electricity, uninterruptible power supply, which lead to a decreasing PUE factor, where we are on average now at 1.7 in 1.75 in 2018, and it has been up just a bit above 2 in 2010. So there has been some improvements in the infrastructure efficiency around the ICT. Yeah, that shows that there has already been some efforts to save energy. But that also reflects that the traditional way of saving energy is mainly due to infrastructure efficiency, and still there is a huge growth in the need for computing capacity, and also John said the need for the capacities, and that has just increased hugely, and that leads to that increase of server energy consumption and storage and increased network traffic. So compared to that increase on the side of computing power, this is actually a really slow increase, as John already mentioned, that in that period it has quintupled the need for computing capacity. So actually this is an increase, but compared to the output of data centers, it has been moderate. If we look at the share of cloud and edge data centers within the European Union, we see in the European Union we are not adopting to cloud computing as fast as maybe the US and we can see that we like this heavily depends on how you define edge and cloud data centers compared to traditional data centers. In our study, it is defined as like the hyperscale data centers of cloud operators plus an extra of the ICT equipment we see in the co-location data centers, for example, where also some cloud providers who have explicitly cloud equipment are operating their equipment. It's not that the other traditional data centers would not use any cloud-related technologies like virtualization, and so you can have different definitions of that. So that definition is formed as only for the cloud operators, and a special growth will happen, as already mentioned before, in the edge sector, where we have new applications with virtual and augmented reality, like autonomous vehicles, and a lot of other applications that require really low latency between the end user device and the data center. So we will have these distributed small data centers all over Europe, and this could have an share of electricity consumption in 2025, which is already a projection. All from 2018 is a projection here. So in 2025, the edge data centers will account for about 12% of the energy consumption, but only reflect about 10% of computing capacity. This is because those small data centers are estimated to have a bit weaker infrastructure efficiency. So how are we talking about technological development and technologies in the cloud computing? The basic fundamental thing is we have an output of cloud computing and edge data, or output of cloud computing and data centers on the one side, but an energy input which defines the energy efficiency on the input side, and dividing these two brings you to the overall efficiency definition. And so we made a model which includes all the technologies where you have the energy input on an infrastructure side, where you have all the networks, you have different types of data centers, from big hyperscale data centers over corporate to edge data centers and the edge equipment at the network edge. And then you have the whole software stack as well, but you also have a huge part like of the management tools, which are also responsible if you're talking about how efficient all of this can be operated. So in the technological analysis of the study, we also investigated like how these parts affect the final ratio of the production side, which is on the right side here, that comes out like the output is infrastructure services, platforms and functions, and software and applications, which come out at the different parts of the like at the software layers, and the energy goes in at the physical layers. So we've defined 6 key technological areas. they are the ICT hardware itself, then the infrastructure, which is also needed to operate the ICT hardware. Then we have the communication networks. We have all the metering and control and analytics tools. We have the cloud computing management tools, and we need the software itself, the application software, to be efficient, to operate, to implement these processes and the services very efficiently. And one of the most important factors for energy efficiency, I have an extra slide for that, is Moore's law and the Dennard scaling, which describe like the miniaturization of ICT technology over the time. You all know that probably, and still there is discussions ongoing since a long time how long this will be possible. But the closer we are coming to the physical limits here, the more important is we need to look at like other technologies, new approaches, quantum computers, for example, to still have new technologies to power our new applications, which are really compute hungry and storage hungry, and we need some new technologies to power them. Otherwise, they will be very energy hungry in the end. And this is a part where we still need some research. And you can see the IP traffic has increased by a factor of 19 within the last decade. So looking at this growth factors shows you just how efficient, like how important the energy efficiency of new technology is for the overall efficiency in cloud computing. Another point that is really important is software efficiency. It has not been looked at this so much in the past. There were some strategies and approaches to have more efficient software solutions to power the same applications with less ICT infrastructure or like ICT hardware, and therefore yeah, we need to look at this field a bit more than we did in the past. But there is some ongoing processes. For example, the Blue Angel in Germany, which has a label for efficient software products, and I'm really interested how this will develop in the next years. So we also have suggested some recommendations for further future policies. They are quite in line with the green paper I've seen here from the Horizon Cloud project. And those were mainly designed by our colleagues from the Environmental Agency. And so I just give you some examples, what has been described there. So for research and technological development, of course, we need energy efficient computing and storage and network equipment as described before. We need the software efficiency, and we include the overall carbon emission of the energy system as well, more if we calculate cloud computing impacts on sustainability. And but there is also a huge impact with the green public procurement, because the public bodies within the European Union, the member states down to the local institutions, are really important with their purchase decisions. So there are already some guidelines for purchasing green ICT services from data centers. And they have a huge impact as they are a big customer within the European Union. And there is already some policy in work right now, like the eco-design for server and storage equipment. There has been already some great work being done, but we need to further look at the new technologies like edge data centers and maybe software efficiency, where policy can help to implement only the most efficient technologies. And I think also initiatives as Gaia X can help to bring more transparency into the whole sector, where you can better compare different operators of cloud and data center infrastructures for making it better comparable for the customers. And also already said by John was the like new standards and KPIs really important. So my last slide for today is the future really depends on where we're going at. So for future projections until 2030 is really hard, because ICT sector everybody knows that, is quite hard to estimate what the future will bring, especially now with where it's not clear where Moore's law will go to. We see that edge computing, for example, can add some like 20 terawatt hours to the expected data center energy consumption. If that is just going faster than we expected right now, it is already expected here that some percent of edge data centers will be in work until 2030, but it could be even more. And especially if Moore's law go down, like the data center energy consumption within the EU could rise even stronger. But if we have some really efficient approaches, we have some good policies out there and good technological development, the data center energy consumption in 2030 could also decrease to the levels back to where it has been in 2010. So there is a huge potential in having new approaches and new policies out there. So this is really important to talk about that. So thank you very much. And I'll hand back to Paolo.
Thank you, Simon. This was a very interesting presentation. I think the need for collecting more data on the consumption of data center new is evident. We also have done some research and came up to very similar figures to what you have. However, I would say not only these, but we should also try to include the system figures. So all the data transmission that is going into data center and coming out from the different devices, from mobile phone, PCs, and more machinery connected to the IoT. So it's really interesting to show that what is the data center part and what is the other connected consumption, and say, of connected system and transmissions.
Absolutely.
And this is what is needed, of course, by the European Commission to come forward with new legislative proposals. It's good that both you and John have mentioned that both the digital strategy of the European Commission and the Green Deal put a lot of emphasis on decarbonization of data centers and telecommunications. And to do so, there is needed a lot of brains to really to decide how to go about, because it's very complex. An example is I think 15 years that key experts around the world are trying to define the ultimate efficiency of a data center with an indicator or set indicators, but we are not there. There are big progress in ISO, but I think to capture really, as we do for a cement plant where you have ton of cement divided input energy, we don't have something similar yet for data center. So thank you again. Let's move on to the next speaker, which is again is a friend and has been working for many years with us in the Code of Conduct and is a great expert on data centers and data centers energy efficiency. And the speaker is Mark Acton, now with the company EkkoSense. And as I said, Mark has been for many years supporting the best practice document as key editor of the underlying European Code of Conduct. Mark, the floor is yours.
Mark, we can't hear you.
Can you hear me now?
Yes, thanks.
Yeah, sorry about that. I was on mute. I was on the slideshow and on mute. So, schoolboy error. Can you see my screen properly now?
Yes, we do.
Good, good, thank you. So apologies for the technical hiccup there. And many thanks, Paolo, for the introduction and for the excellent presentations from both John and Simon. Hopefully I'll be able to refer somewhat to those presentations in my presentation. I'm very conscious of the time, so I'm going to move on quickly and stay within my allocated 10 minutes. What I've tried to do in this is look at the paper that was published and according to the brief, look at the paper and then maybe make some comments against that paper on some of the statements that are made and some of the challenges that I think we're facing when we're trying to achieve both energy efficiency and increasing sustainability. The first one I'm going to address, again, this is from the paper, is SG Challenge 1. And there's a couple of statements here that I'd like to kind of just pick up on and maybe reference. The first one is that the data center energy efficiency standards landscape is weak. Yes, I think we have a challenge there, which I'm going to go to on the next slide. But it's not that the standards landscape is weak. I think it's more that we actually don't have an energy efficiency metric. And I'll come on to that later. I think the idea of developing energy efficiency standards for Europe, absolutely makes perfect sense. And my final slide actually will reference this in particular. And then finally, starting from the KPIs that exist, but choose them wisely as some are no longer fit for purpose. Well, I'm going to challenge that statement slightly. I think they are not necessarily no longer fit for purpose. They are probably used inappropriately, which is not quite the same thing. So I'm going to move to my first slide. So I'm going to give you an overview of the KPIs that actually exist. Now, the worrying thing about our sector and people looking at our sector and commenting on our sector and even possibly trying to legislate for our sector is that they don't necessarily understand what's out there and already available. So we actually do have a number of metrics and KPIs defined by ISO IEC. So these are global standardized KPIs and metrics. So as you can see here, we've got PUE. So most people outside of our industry and an awful lot of people inside our industry don't necessarily appreciate that PUE is defined by a particular document, which is ISO IEC 30134-2, and it's quite concerning that I know that. Nonetheless, that is the right way to measure PUE. So when you see people making statements about PUE and talking about instantaneous PUEs or other sorts of nonsense, they clearly don't actually understand what PUE is, and they're clearly not using this reference document. And so some of the figures that are out there referencing PUE are open to question and debate because they're probably in many cases not based on a true standard. Going beyond that, we do actually have some additional KPIs and metrics, again, which are standardized. So we've got renewable energy factor, how much renewable energy we're actually using. IT equipment energy efficiency, interesting, looking at the IT side. Equipment utilization for servers, again, utilization. We've then got the energy reuse factor. John talked about, the potential for reusing energy. Well, here's a metric that can benchmark and standardize how that's actually measured and reported. And then we get into other areas such as carbon usage effectiveness and water usage effectiveness, which again directly relate to sustainability. So we do actually have quite a lot out there. And these are new, these aren't necessarily old. Some of these have only been published in the last year or so, and some are actually still to be published in their final version. So these are legitimate, they are relevant, and they are new, but I'm not sure that many people necessarily know about them. So to say that the landscape is weak is not strictly true. We have certain elements missing, that is true, but the landscape generally is not necessarily that weak. I'm going to go on to another statement or series of statements. There are no global energy efficiency standards with which to evaluate data centers. That is true. There is no single energy efficiency metric for data centers. And there's a number of reasons for that. One is that not all data centers do the same thing. What a high performance compute center does versus a center that's potentially streaming videos, content distribution network, something of that nature. They are very, very different things. So trying to measure energy efficiency from those sites is extremely difficult, as Paolo suggested earlier. It's not only that we don't have a standard data center in any shape or form. We also, if you think about it, the definition from a physics perspective of energy efficiency is energy consumed for useful work done. It is extremely difficult to define what useful work is in a data center context, and that's where one of our problems lies. So we cannot produce a scientifically valid or a useful metric based on science or pure physics that actually gives us anything that we can pin our hat on with regard to data centers. Moving on, the most widely used metric is power utilization efficiency, PUE, which is easy to understand but difficult to measure correctly. It is easy to understand. It's very, very simple. It's a simple ratio. Difficult to measure correctly, I challenge. It is actually very easy to measure correctly. Again, I reference the document that tells you how to do this, which is part of the ISO IEC standards range of 30134. It's difficult to measure correctly if you don't reference a document, I agree. But actually, if you've got the right metering in place in your data center and it's not complex at all, it's actually very easy to measure this properly. It's very, very easy. There are different levels of accuracy. There are 3 levels of accuracy represented with PUE. So getting the right level of accuracy or the highest level of accuracy does require quite a high degree of granularity. But nonetheless, measuring is fairly easy. Certainly if you want the less accurate levels of granularity. The other thing about PUE is it's not an energy efficiency metric. It isn't. You know, people use it as such, but it's not. All it does is measure the amount of energy that the building consumes in supporting the IT load within that building. What it doesn't do is address how efficient the IT load is itself, which is actually the consumer of the energy. The building doesn't consume the energy. The IT load consumes the energy. The building puts an overhead on delivery of that energy to the IT equipment. So PUE doesn't even measure the issue that we're trying to address. The statement that most existing KPIs are mathematically related to PUE is not really true. And again, if you look back at the list that I showed you, there is, yeah, you can argue that they're mathematically related in the sense that they are ratios, but that's about the only relationship they have. So it doesn't really, you know, that is not really an accurate statement. And then finally, notwithstanding this, there are some interesting activities making the moves in the right direction. Absolutely true. If you look at the Senelec-led EN 5600 series of data center standards, that's exactly true, and we'll have a quick reference to that later on, which is here. So the EN 5600 series of standards, this is again created in Europe by Europeans for Europeans. I think we should all get behind this. We should all use it. You know, we seem to insist in our industry of using standards created elsewhere outside of Europe. But this is a genuine standard. It's a genuine European standard. And I think, you know, again, more of us should get behind using it and understand that it's out there. Interestingly, one of the things it does do is reference those standardized ISO IEC KPIs that I mentioned earlier. So they are actually incorporated within the EN 5600 series. So not only are we using potentially global ISO standards, but actually we are referencing those global standards within European standards. So again, you know, everything ties together quite nicely. We should be more aware of this and make more reference to it, as I said, within our sector. The code of conduct, Paolo mentioned the code of conduct, something which is useful and actually does crop up routinely in reference in European documentation. You know, for instance, someone mentioned the Green GPP, the Green Public Procurement Policy. So it pops up as a reference in that, and indeed in the Green Paper that we're all referencing on this event. It is free to download. It is updated annually. The next revision will be due in January 21. So we're currently working on version 11. That'll be version 12. It is voluntary, but it's a useful reference. I think that the most important thing to say about the code of conduct is, as John said, you know, 160 odd best practices. If you implement them in your data center and understand them, you will save energy. It's pretty basic and simple. I'm not going to say any more than that. It's a bit of a no-brainer, really. The interesting thing about the EN 5600 series, just as a reference, is that it's actually been incorporated into an ISO IEC series. So not only will EN 5600 continue to be a European standard, an existing European standard, and it will continue to be updated, it's actually forming the basis of an ISO IEC standard. So actually, by reference, EN 5600 is effectively going to become, if not a true global standard. It's certainly the reference point and the starting point for a true global standard going beyond just Europe. So that's it's worth knowing about, and that probably gives some idea about how powerful and how useful the EN 5600 series actually is. Green ICT challenges from the paper again, and Simon did reference this. I'd like to point to the second statement. Data center and network operators should report their energy consumption and environmental footprint. True, but at the moment, all we seem to do is report data center energy consumption as a whole. We just say how much energy buildings are consuming. Well, that's not particularly useful because we don't understand the actual efficiency of the IT equipment that's within those buildings, and more importantly, the actual consumption or the effectiveness and the efficiency of the consumption by that IT equipment. So yes, we're reporting at a very macro level, but actually it's not particularly useful. What we're not doing is addressing the IT element, which is really what ultimately cloud's all about. And by IT, I don't just mean within data centers. I think I go back to Simon and Paolo's point, it needs to be the entire ecosystem. It needs to be the network. It needs to be the mobile devices as well. But, the easy thing to do in theory is measure what's in the data center, but we're still not actually doing that properly. And that goes on to the statement from page 68. Measuring a closed system like a data center with all its complexity is still simpler than the bigger picture. Absolutely true, 100% true. But if we just do that, and we just concentrate on that, and we concentrate on the building, then we're probably not really getting the information required, which kind of is what Simon was alluding to in his presentation. There is a great deal of uncertainty about some of the numbers that we see in regard to energy consumption, and particularly in regard to the IT load within that overall energy consumption. The statement there, we don't even have reliable numbers on how many data centers there are out there, is absolutely true. There's one public body, I think it's Servista, I think it's called, which claims that there are something like 8.4 million data centers out there. How they determine what a data center is anybody's guess. But 8.4 million is quite a large number. Gartner, in a recent paper, I think dated August 2020, suggested there are about 3.5 million of different types. So again, we've got widely varying figures from reputable organizations. The ultimate answer is we don't know. We actually have no idea. It's guesswork. Finally, and this pretty much is my final slide, we talked about European standards. We talked about the need for European standards, which are focused on European requirements. Again, 100% agree with that sentiment. But what I'd like to do is point to ASHRAE TC 9.9, Technical Committee 9.9. As the title suggests, this is the American Society of Heating, Refrigeration and Air Conditioning Engineers. So why is it important? Well, it's important because every data center on the planet, practically, including all those in Europe, are guided by ASHRAE environmental guidelines. We use those to determine the temperature and the humidity and other factors within which we operate our data centers. That's not because it's a good thing to do necessarily for the data center, and it's not necessarily because it's a good thing to do for energy efficiency. We do it because we need to maintain the equipment warranties on the IT equipment, which is based in those data centers. Those equipment manufacturers, typically US based, not exclusively, but typically, have all agreed to abide by warranties based upon ASHRAE guidelines. So the reason we operate the data centers to this manner, which again may or may not be energy efficient, I'm not even going to go to that element of it. There's a debate, it may be, may not be, but we operate to those conditions because that's what will sustain the warranty on that equipment which is installed in it. And if you think,
please, sorry,
yeah,
wrap up. Thanks.
Okay. So when you consider that the IT equipment is probably, in terms of value, 100 times more expensive than the building itself, that is an important metric. So people do follow this guideline. Maybe one thing that we need to consider going forward is, rather than relying on a US only standard, this is a standard in the US, it's not a standard globally, but it is a US only standard, US national standard, is maybe having something that replaces this for European operations. So that may be an initiative that we should potentially consider. Is it an inhibitor or enabler? I would suggest it's probably an inhibitor at this stage. That's it. Sorry if I went slightly over, I apologize. It was a bit of a brief run through.
Thank you, Mark. Very interesting presentation. I think the landscape of standards is very important to understand what is out there, what we need to further work on. And might be a question mark is, once you have all these nice European standards, which are very important, how much training and information to the single operator or manager in the data center floor is available to make them aware of this? So I know you cannot answer that now because we are out of time, but it's a question for you to think about and a bit come back in the chat.
Sure, it's a good point. Thank you.
Okay. And without further ado, let me introduce the last speaker, Andreas Ebert from Microsoft, is going to present a sustainable cloud for greener Europe. So Andreas, the floor is yours.
Thank you, Paolo. I have a quick question. I think officially the session is ending in 1 minute. So how do you want me to spend the time? How much time do I have?
Alessandra, can you comment on this?
If you can be very quick, but I guess you'd like to share with you your position. So let's say 5 minutes. Is okay for you?
Okay, I'll try my best.
Thank you.
Thank you so much. Good morning, everybody. Thank you for having me here, and it's a great opportunity for this important topic. Let me start quickly by the commitments our company did. We started our journey back in 2009 with carbon emission reduction goals, but 2020 was really a year where we started a holistic approach across all climate impacts. So in January, we announced our goals to be carbon negative by 2030. We want to remove our historical carbon emission by 2050. To get us basically historically carbon negative by 2050, and we will make a $1 billion climate innovation fund available, which has already been started to be used for things like water preservation and water-oriented kind of things. In April, we announced basically the Planetary Computer Project. Think about this open source, open data-based initiative like a digital twin of the planet's nature. And in July, we helped our customers to leverage the power of technology and offer the Microsoft Sustainability Calculator so they could see for every single function they're using in our services, like Azure services, sorry for using product names, the kind of energy consumption and the economic environmental footprint this application is using. We also introduced the Supplier Code of Conduct thing in July, and in August we announced basically Microsoft Circular Centers to create basically a system to address the waste problem, which has been mentioned in the first presentation. We are also constantly investing in European data center infrastructure and to meet basically the demand of computing power and storage capacity in Europe. And we announced new data centers in Spain, Italy, France, Germany, Norway, Switzerland, Austria. Maybe I forgot some of those, but most recently in Sweden last week. And as PUE has been mentioned quite often, the average PUE of the most modern versions of the data centers are currently in the area of 1.1 roughly, depending how you count. And I think it's a topic which should be mentioned. The other thing, in Sweden, we are partnering with Vattenfall, an energy company, and we are using as the first hyperscalers, they're very innovative 24/7 renewable energy tracking solution so that we can track on the hourly base what the share of sources of renewable energy is in using the data centers. I've read the hCloud green paper with interest, and I want to point out a couple of things from an observation perspective. So number one, data center architectures are rapidly evolving. Just in our own company, in the last 10 years, there were probably 5 archetypes of data centers, which this rapid innovation is driving in a way, and any metric leveraging basically then the benefits of this one should accommodate this architectural flexibility, which are the key drivers for basically progress in this domain. The second one is that data centers are basically infrastructure, hardware, however sophisticated they are, but they're basically useless if there's no applications using them. And the energy efficiency of applications in itself, it's not the energy efficiency of the operating environment of the data center operator. I'm talking about the application layer in itself could make a huge difference. And I'm using an extreme example to make my point. Others might not have the same numbers, but if you're taking a very frequent algorithm like matrix multiplication, which is very often used in high performance computing, and you code it in JavaScript, and the second person is using and highly optimized compiler, leveraging every single bit of hardware advances a CPU can do. The performance difference is 60,000 to 1, and the energy difference is 10,000 to 1. So inefficient software is offsetting most of the energy benefit and sustainability benefit optimized hardware can do in a way, and I would suggest that the Commission is continuing its kind of investment in helping people to understand how to write effective software and basically creating transparency about this offset between two extreme things. One is software developers' productivity and environmental sustainability on the other side. There's also disruptive, 2 more minutes. There's also a disruptive set of technologies coming on the horizon. So it has been mentioned quantum computing and biological computing, which are interesting because they're basically fixed energy architectures. So the cooling is, of course, maybe a kind of intensive activity for quantum, but it doesn't make any difference for the energy consumption of a quantum computer if it's idling around or fully loaded, because the difference in energy consumption during processing is can be ignored almost. Then the change in distribution of workloads requires optimized hardware. I don't know if you have tracked, but the machine learning models currently being done have increased in the last 5 years 300,000 times. And if algorithms and hardware isn't optimized for this new type of workload, which is basically graph-based applications, energy consumption goes up to unacceptable kind of levels. So innovation is necessary at this level as well. The other thing, what is still an open issue in the CMOS hardware world, is that energy proportional hardware is not available. So you have always this kind of situation that if a data center or the server, for the sake of conversation, is idling around, almost 60–70% of the maximum energy consumption is still used without any actual workload. And then 100% workload means 100% on this one. But true energy proportionality is currently still far away. And I think that would warrant a great research agenda for Europe as well. And the other thing is around basically creating a measurement system around cloud federation. Because currently the edge and federation concepts are one of the kind of developments we see in Europe, in the market and customer kind of things. But usually the energy consumption is being mentioned at individual node level, not at systemic level. And if you do, for instance, big data processing at federation level, you have to replicate a couple of assets, compute, storage, encryption, compression, decompression. And so I would recommend to consider in any measurement system on cloud federation, a systemic view around how much energy is the total application using in this domain. And in case you want, you can potentially put it in comparison to other kind of cloud deployment models. I will stop here given the kind of time, but thank you so much for having me here. And if there's any kind of offline or online question, I'm happy to participate.
Thank you, Andreas. Such a very intensive and interesting presentation would have deserved at least an hour and a full lecture, but we know it's impossible. But I maybe encourage participants to put questions to you on the chat or maybe to contact you to really dive into so many interesting concepts that you have illustrated in such a short time. Thank you again.
You're more than welcome, and thank you so much for having me here.
So I think with this presentation, the session ends. So I would like to thank you all the speakers. Apologize again for being late. And it's been an excellent session that I will try to summarize now in the plenary session. And I give back the floor to the organizer for any housekeeping information.
Yes, you can just click on the link that you will find in the chat box, and we can all go back to the plenary session. Thanks a lot.